This is a quick video to demonstrate a little project I've been working on. It's a fully programmable RAM and ROM card for the KIM-1, and as you can see, it is based on a Raspberry Pi Pico W, and it has some cool features, I think. So let's plug the card into the KIM-1. Let's turn it on and let's see how it works.
Okay, first of all, sorry about the audio quality. The mic is not placed where it should be, but it is what it is. Anyway, the KIM-1 is up and running. The video output is connected to the monitor you can see in the upper left corner of the screen. And right now it's not displaying anything because the video memory is blank, so there's nothing to display. Sorry. Let's see what is the memory map configuration. For that, we use the config command without parameters. First, we have a RAM area from the very beginning to the start of the input-output addresses of the riots. This means that we are taking over the system RAM, so this KIM could be running with damaged RAM or even with no RAM installed. Then I've disabled the addresses of the input-output of the riot input-output, so the KIM-1 can function normally. After that, a very small RAM area that corresponds to the RAM included into the riots. Then a ROM area that takes over the system ROMs. It has basically the same KIM-1 system ROM. I've just made a small modification to add a command so I can launch Corsam's extended KIM monitor. Then large RAM area, and finally some ROM which contains the extended Corsam KIM monitor with my modifications for IEC support. This is a default configuration that loads every time you turn on the board, but you can modify it or you can flash a different one to suit your needs. Also, once the KIM is up and running, you can change the configuration at any moment. So you can enable or disable new areas or make or convert RAM to ROM or vice versa. So let's check that. So if we inspect the memory starting at 400, we can see it's empty, blank. So we can add some values. Let's see if they are there, as they should. Okay, so if now we disable this RAM area, and we try to display what's in there, you can see that there is nothing. It's displaying, in fact, it's garbage. The card is not placing any data at all into the bus, so these values are completely garbage. If we enable this RAM again, we read back the information that was there. Another thing we can do while the KIM is running is to read any part of the memory and dump it into the screen or to any file into the PC in Intel hex, binary, or PRG formats. So let's check that. Let's see. Dump the contents of the memory we've just modified, so you can see the values we added, or we can read the ROM contents. Or any other part of the memory map. Also, you can modify the memory when the KIM-1 is running. You can write to any address of the memory map. It doesn't matter if it is ROM or RAM. That can be read from files in different formats, binary, again PRG or Intel hex, or for small modifications you can also place the data in a string using the command line. For example, as you see here, this is the KIM prompt. We're going to change it to some other thing. Sorry. And now, as you can see, the prompt is different. Of course, we can also load programs into the memory. Let's check this other memory area, 4000 hex, which is empty. And now we are going to load KIM basic from a PRG file. So again, okay, you see how fast it is. Now if we check that area again, you can see it has data, and we can start the program. Okay. Regarding the video emulation, now it is configured with the start address at 2000 hex. So we're going to load an image to that address. And you see that almost instantly the image is displayed into the screen. We can change the start address of the memory of the video emulation. For example, let's change that to 8000 hex, and immediately you see that the display is showing some random bars that correspond to the information that the pattern that the Microsoft Basic writes to memory to locate the end of the RAM. So if we now load another image here, you see that is displayed. If we change the address of the video memory, the image of course changes. So this is it for now. Thank you for watching and take care.